Negative 12.1. Negative 13. So what would the graph of this look like? These are pretty tiny in here. What we're going to do is I'm going to make two lines equal 1. So I'm going to change my scale here. So each line is a half. So I got 1, 2, 3. I want you to do the same thing. This actually is a pretty cool graph. It's not just a boring old V or anything like that. So 2 lines is 1. Otherwise, this graph is going to be really, really ugly. So the 1 should be here. Because it's half 1. So remember, start at 0, don't start at 1, start at 0. So as you're finishing up setting this up, I want you to be thinking, what's the answer to the greatest integer between anything from 0 to 1? So any number between 0 and 1 is going to get rounded back down to what number? 0. So if I have the greatest integer of 0.5, that would round down to 0. 0.6, 0.99, 0.9 repeating. We can get another discussion. 0.9 repeating, that is the same as 1.
Between negative 1 and 0.
So in between negative 1 and 0, that would get rounded back down to negative 1. So what's the greatest integer of 0? 0. So we're going to put a solid circle at 0. And what I was asking there is, you're saying anything, if I pick any x value between 0 and 1, that's going to get rounded back down to 0, correct? So we're going to draw a horizontal line right along here. We're going to go right up next to 1, but now what's the greatest integer of 1? What does 1 round down to? 1. So we're going to do a closed circle, horizontal line. This is going to be an open circle here. Okay, can you zoom in a little bit more? Yes. Now at 1, you said the greatest integer of 1 is 1, so I'm going to jump up and I'm going to put a solid circle at 1. Okay, so now x is 1. I'm going from 1 to 2. Anything from 1 to 2 is going to get rounded back down to 1. So I'm going to have another horizontal line right here. And I'm going to do an open circle right there. Because at 2, guess what it jumps up to? 2. So guess what we're kind of making here? Yeah. This is also called a step function, because it makes steps when you graph it. What's that? No, just this. You do not connect these vertical parts. Good question. You do not connect the vertical parts. These are what we call a jump discontinuity. The graph jumps. They're pretty cool. Aren't you glad you came today? You can draw some step functions on your church bulletins this Sunday. Yeah, you know it.
Yeah.
Okay, so you can keep going because we can go the other direction as well. Now, if I go to the negative side, anything between -1 and 0 is going to get rounded back down to -1. There you go. You just drew your first greatest integer function, or your step function. This is also going to be called the floor function. How many names can you come up with this? Around them. Yes. Calculators can graph it. You know where we found the absolute value? Under the math menu, the right arrow. I think option 5 is INT from integer. That's the function. Now, your calculators will probably it won't understand this jump, so it'll probably put a vertical line in there. I know a few ways around that also. Yeah.
Or we can put this in the...
You can. And you can also do it on Desmos. Okay. So, before we do that, let's do domain and range with this, and I'll show you the calculator. So what's the domain for this? Domain is the x. What x values can we use here? All of them. Because if x is 2.5, I have a y value. If x is -3, I have a y value. So x equals all real numbers. What about the range? What's that? Oh yeah, a favorite. Mr. Lizzie's birthday. Not all real numbers. Where does x equal 1.5? Where does y equal 1.5? Okay. You see the y values we're using are 0, 1, 2, 3, 4, 5. We're not using things in between. Y never equals 1.5. There's no x value that matches up with that. What's that? So if you remember, the symbol for integers is a z. Okay. Now it's not always going to be integers. It can adjust and change, things like that. Okay. Now, I know I've thrown lots of names at you. I'm going to throw what I've just said here. This is called the greatest integer. This is also referred to as the floor function. Where's the floor, above or below us? Below. Where are all these numbers being rounded down to? Below. Okay. So if you ever see this, okay, if you ever see that, that is same thing as that. Okay. Now, if there's a floor function, what's the opposite of the floor? There's also going to be a ceiling function. So what do you think the ceiling function does? Rounds up. It's the only difference. Okay. Instead of these ticks down here, they'll be on top. So this is the parent function for the greatest integer or the floor function. This is the parent function. So could we translate this right, left, up, and down and move it around? Yeah. Okay, it follows the same properties, same rules as the absolute values, as the quadratics, as the constants, as the linears, all of that. Okay, so these can be adjusted. On your calculator, to graph this, you're going to go back to the math menu where we found absolute value. Okay. So math menu, right arrow, and option 5, integer. Good job, Bethany. Option 5, integer. Oops. You can put it as Y1, that's okay. Now, I think Kale's, yours will look pretty good. The rest of you will probably look like mine, where it shows those little vertical steps. Yes. Go zoom 6. Okay. This is the difference in the two types of calculators. Okay, Kale's, yours probably look like that. Okay. You're going to type in the integer of x. Integer is found underneath the math menu.
But I think it's bad in the calculator because it doesn't appear like a line. It doesn't appear a line.
Oh, you have to iterate, and then you'll be on the line. So you have to go straight, and then you can follow the line. Let's see what yours looks like. You get yours? Got it? Okay, now, on these 83 pluses, this is the difference between an 83 plus and an 84. On these 83 pluses, if you don't want those vertical lines, go back to y equals. And you're going to change how the drawing mechanism over here on the left. So on the y value that you typed it in, you're going to go over here. So go over there, press enter until you get these 3 dots. I think it's the last one. You're going to be looking for that right there. Okay, now hit push graph again.
Yeah.
Should look better. Everything look good? Everyone following along okay? I think it's like 6 times. Okay. So what would happen if I put a negative on the outside of the integer? It would now let's use our math terminology. It would reflect over the
Y.
x-axis. The last assignment, then you got that confused on the last one. It's going to reflect over the x-axis, so now your steps are going down. So now you can go downstairs. Okay, come on. I know you got another interception, but you still can't. Okay, Nate. Make sure you're doing. Oh, remember you have to insert. You have to retype the whole thing. If you press enter on the equal sign, it turns into